Hi, I'm Carlotta A, and I'm a professor of electrical engineering and robotics, and I'm also an open source hardware trailblazer fellow. My project is called Robotics for the Streets, creating open source robotics to enable academics to engage in service, research, and teaching. I have 3 levels of robots for that. I have Lily bots, Daisy bots, and Rosie bots. Today, I am going to show you how to add a sonar and infrared sensor to do distance sensing on Daisy bot. This could be used for wall following, object tracking, obstacle avoidance, or anything where you want to detect an object. You could also use it with other sensors such as a color tracker to detect certain objects. Please come along. I hope you enjoy and stay STEM-tastic. So here's the wiring diagram created in Fritzing for the Daisy bot. In the upper right hand corner on the left we have the infrared sensor. On the right we have the sonar sensor. All of the grounds go to ground on the breadboard. All of the voltages go to 5 volts on the breadboard. And for the IR sensor, the signal is attached to pin A13. For the sonar sensor, the trigger is on A14 and the echo is on A15. Now let's take a look at what it looks like on our robot, and then we'll write our code. So here we have the sonar mounted on the right side of Lily, and we have the 4 wires coming out. We have the black going to ground, and then we have the purple going to 5 volts. And then in the middle, we have the trigger, the white wire going to A14, and the gray wire, which is the echo, going to A15. Then on the left side of Daisy bot, we have the infrared sensor that comes over here to the breadboard, where the red wire goes to 5 volts, the black wire goes to ground, and then the green wire, which is our signal, goes to A13. So now let's examine the code that enables Daisy bot to use sonar and infrared sensors to detect objects. We will focus on the new pieces of code that have not been explored in previous videos on motion control. So first, we always have a comment at the top that describes what the program does. Then, before the setup function, we define our range sensor variables as the IR pin A13, the trigger pin A14, the echo pin A15, then our global variables, the sonar distance, the IR distance, as well as a detect distance, which we will set to 10 inches. In the setup function, we set the IR pin as an input, the echo pin as an input, and the trigger pin as an output. In the loop function, we are going to read our switch pin, read the sonar distance, and read the IR distance. The switch pin is used to determine whether the robot is on or off. If the robot is on and we detect that the sonar and the IR are less than 10 inches, then the robot should drive forward. If only the sonar is less than 10 inches, then the robot should pivot to the left. And if only the IR distance is less than 10 inches, the robot should pivot to the right. If there are no sensors triggered, the robot should stop. We continue to read our switch pin, or if the robot is off, the robot stops. There are 2 helper functions that we use for this code. The first one is sonar read sonar distance. So we have an echo time and the calculated distance. So we set the trigger pin high, wait 10 microseconds, set the trigger pin low. Then we pulse in for the echo pin. Once it arrives, we take that time and divide it by 148, and this returns our distance. For the infrared sensor, we have read IR, which reads our analog pin. Then it calculates the voltage by multiplying that by 5 and divided by 1024. This is a sharp IR sensor with a power equation that is 29.988 and a power function, volts raised to negative 1.173. Then to calculate distance, we convert centimeters to inches by dividing by 2.54, and we return the distance. Let's take a look. So now that we've written the code, let's see what it looks like in action. So I've already flipped the switch so that the robot is on, and right now the robot does nothing. But let's see what happens if I trigger the IR sensor with something that's less than 10 inches away. I'll use my hand. And you see that the wheel moves forward when I have something close to that side. Let's examine what happens if I trigger the sonar distance less than 10 inches. And then let's see what happens if I trigger both sensors less than 10 inches. So these would be examples of avoid on the right, avoid on the left, or either avoid on both sides or follow hallway. And so you could use this for wall following, for obstacle avoidance, or object detection.